Um, okay, oops. This video is about tips for learning calculus. So I have a lot of tips for learning calculus that I think would be helpful, and I think they're actually helpful for math classes in general, but I'm thinking about calculus in mind. And I have experience working with students, taking a variety of math classes. I've taught math classes at the university level, and I probably have been a TA for well over 1,000 students by now, and I have a pretty good idea of my sense of how students can go about learning calculus effectively. And a lot of the students who take calculus are freshmen. So I'm going to assume, even though this might not be you, I'm going to assume that you are entering college and this is a new environment. And so some of the tips I might say might be kind of basic to students who've been in college for longer, but I think it'll be helpful for a lot of students. So, and there are lots of different calculus classes. So things I might say might not be applicable to you, to your calculus class, but my background is calculus classes in large universities. So a class size might be like 100 students. There are colleges, and this is in the US, and there are colleges where a calculus class might be more like 15 students instead of 150. But I'm going to assume that you're going to be taking a class in a university with a graduate program. So there are going to be TAs, and you go to a lecture maybe Monday, Wednesday, and Friday, and then you go to a discussion or recitation or quiz section, whatever it's called, on Tuesdays and Thursdays. So that's a very typical setup. Okay. So the first tip, and this is in no particular order, but the first tip, which I think is the most important, is to make sure that you have reviewed your algebra and pre-calculus before starting the class. So the fact is that calculus builds on algebra and pre-calculus. Now, I'm assuming that this isn't a business calculus class because a lot of business calculus classes don't require pre-calculus. But this is like calculus for engineering, life sciences, that sort of thing. Physics, right? So calculus does build on algebra and pre-calculus. And the fact is that there's nothing I can say that will guarantee that you're going to get the grade that you want in calculus. I think everyone would like to have like an A+ in calculus or whatever, 4.0, whatever the GPA is. But there's nothing I can say, there's nothing your professor can say, there's nothing anyone can say that will guarantee that that's going to happen. But you can increase your odds of getting the grade that you want, or learning as much as you want, learning the math that you want to learn, that you want to get out of the class. And the more algebra and pre-calculus that you're comfortable with, the better your odds will be. And the less knowledge that you have of algebra and pre-calculus, the lower your odds will be. Okay, that's just a fact. Like, that's not negotiable. So factoring, distributing things, simplifying things, and not just like randomly canceling things, right? Understanding that when you cancel your dividing the top and bottom by something, or you're, and you can only do that when you have a factor, right? Or things like understanding what 1 over x looks like, or the domain of a function, or how to tell when a function is positive or where it's negative, and basic pre-calculus stuff. And also things just like setting up a problem, a word problem, defining a variable and writing in equations from the problem. These are really important basic skills, and those skills are actually more fundamental than anything you learn in calculus. So the more math background you have, the better your odds will be that you will achieve whatever goals you have when it comes to the calculus class. Now, what happens, because a lot of students don't have an optimal algebra or pre-calculus background. So a number of students, for instance, might not have taken algebra or pre-calculus in a long time. So they might have taken this stuff a long time ago, but then they did other things, and now they're taking calculus because that's what they placed into, but then they haven't thought about algebra or pre-calculus in a really long time. So in the summer, if you're going to take calculus, say in the fall, which a lot of people do, you try over the summer to review some algebra or pre-calculus. Now, how do you review the algebra or pre-calculus? So a lot of the time, a calculus book, the first chapter will have a review of the algebra and pre-calculus that you'll need. So things like functions, how to tell when a function is positive or negative, graphing functions, basic facts about exponents and logarithms, basically algebra and pre-calculus will be in the first chapter of the calculus book. That's often a good place to look. So if you have a calculus book, check out the first chapter, or maybe there's an appendix or something with a review. Read it, do some of the exercises, check your answers with the back of the book, and see if that refreshes your memory. Okay. So that's one tip I would have. Another way you can review your algebra or pre-calculus is to look at old exams from an algebra or pre-calculus class. So let's say that you're going to take calculus at the university, and the university has a pre-calculus class. We'll take a look at if they have old exams available on the website. See if you can find some of these old exams and just look at them and see how many of those you can do. And it's better if they have answers, but if they don't have answers, at least you have an idea of what things you could review. Okay, so review algebra and pre-calculus. That's number one. That's probably the most important tip, because the fact is that if you don't have a decent fluency with algebra and pre-calculus, it doesn't really matter what you do. Your chances of passing calculus are going to be low, no matter how hard you try, no matter how hard you work, no matter what you do. You could be studying 24/7, but if your algebra and pre-calculus skills aren't pretty solid, then you're not setting yourself up for success, and you want to set yourself up for success. So I would try to review that over the summer before starting the class that you're going to start in the fall. Okay, that's number one. Now number two. So this is where we get into the lectures. So how do you get the most out of the lectures? Okay, let me give some indication of how lectures work at a college setting, at a university setting. So I'm assuming this is a big university. So let's say you are going to take Calc 1. There are certain things that your professor has to cover in the syllabus in Calc 1. There's like a standard list of things, standard list of sections in the book or whatever that they have to cover. The fact is that it's not possible in a lecture to cover everything that you would need to know in a lecture. Okay. So there are a few ways that instructors handle this. One way is to use the lecture to provide an overview. So they provide an overview, they do some basic examples, and then you are expected to read the book and delve more deeply into the material. So there might be things on a test that are not covered in lecture because the lecture is just setting up the overview. Another thing that instructors might do is to say, well, students don't read the section in the book. They don't do any of this, and I have to cover all of this, so I'm just going to whiz through everything really fast and try to make sure I cover everything that's in the section. And that way, students might have difficulty following, but at least I'm going to cover all the examples. And so what some instructors do is they just go by really fast, and the expectation is, okay, the students might not follow it, but they'll take notes and they'll review it after class. Okay, that's another way of doing it. The bottom line is, lectures aren't everything. It's not like you go to a lecture and then after you go to the lecture, you understand everything there is to understand. No, okay? Lectures are usually just for getting the basics, like the beginning. So it's the beginning, not the beginning, middle, and end. So you go to the lecture, and then after that, there's everything else that comes after that. So there's doing your homework, right? There's asking for clarification, so going to office hours, and we'll discuss this more. There's practicing, there's reading your book, there's reviewing your notes after class. There's all these things that come after the lecture that are important, not just going to a lecture. So tip number 2, I would say, is review your notes after class. So I would recommend taking notes and then looking at them. So don't just, what I would recommend is that you don't just copy stuff down and then put your notes in your backpack and then call it a day. I would recommend that you do take notes, but then after class, you find some time to just sit down and review your notes. So you just take out your notes. This is like a quiet place, and you just go from start to end. And you go through the basic definitions, you think about, okay, what were the main topics of the lecture, okay, and review the examples. So the examples are very important. Hopefully your professor did some examples. And look at the examples, read the examples, and ask yourself, do you understand how to do the problem? So this might be a problem, and then the professor goes over how to do it. You can cover up the solution and try doing it on your own, and then see if it matches up with how your professor did it. That's one way that you can review your notes. Or come up with a question about your notes, or what's something that you're confused about, or what's something, if you're not confused about it, what's something that another student in the class might be confused about when it comes to notes? Or what would happen if you change the numbers in the example a little bit? So there are all sorts of ways to engage with the notes. So that should take some time, and there's a good chance that there will be something that you're not 100% on. Put a little mark, like a question mark. Take out a pencil and put a question mark on the things that are confusing to you, and then make a plan to ask for clarification about the lecture. Either if you have a TA, ask a TA, or go to the Math Learning Center. Hopefully there's some, most, I think, universities or colleges are going to have some sort of center, which is like a room where you can go and ask questions, or plan to ask your professor directly. That's totally fine during office hours. Just say, hey, I have a question about what you wrote here. And that kind of thing is very typical because, like I was saying, a lot of professors feel pressure to go at a certain pace that is beyond the pace at which most students will understand the material. So you're not expected to understand everything 100% during the lecture. You get the gist of what's going on during the lecture, and then after that, the things that you do, so doing the homework, reviewing your notes, after you do those things, the lecture should make more sense. Okay. And then another thing, which is something that you can do before class, is to preview the topic before class. So let's say that you know that your professor is going to talk about section 5.2 or something in the book. Well, you could, before class starts, look at section 5.2, read through section 5.2, so that you have an idea of what your professor is going to talk about. When you do that, you will probably find that you'll understand the lecture much better than if you had never heard of the stuff from section 5.2 and then your professor introduces it for the first time. So that's something I would recommend. You don't have to read it super carefully. You don't have to read the section very carefully. I would say 5 or 10 minutes. Just a brief, you just kind of skim through it, look at some of the examples, read some of the problems that are in the section, read the introduction, like the beginning of the section, pay attention to any new vocab terms, any theorems, and just whatever examples are in the book. That should not take too long, like 5 or 10 minutes. You don't have to understand everything because it'll be clarified a bit more during the lecture. Another thing you can do is, if you know the homework that has been posted, read the homework problems for that section so that you're familiar with the homework questions you're going to have to do, and then during the lecture, see if you can connect what's happening in the lecture to the homework problems. So one thing I've noticed is that professors generally do pay attention to what the homework problems are and try to make sure that whatever they say in the lecture is connected to some homework problem. So if there's like a homework problem, number 5 on a certain topic, then they will try to make sure that in the lecture they brought it up. They brought that topic up so that you have a better idea about how to do that homework problem. But a lot of students don't see the connection. So the professor might talk about a topic that's relevant to the homework problem, but then when the student sees the homework problem, they might not be able to say, oh, this part of the lecture was relevant to the homework problem. I'm supposed to understand that part of the lecture, and that's supposed to help me with that homework problem. So sometimes students don't see that connection, and that's one of the benefits of going to a TA or going to office hours, is that they can more explicitly make that connection. But it also helps if you know about what the homework problem is before going to the lecture. So that's my third tip, is preview the topic. Okay. But again, 5 to 10 minutes, not something that's very time consuming. And this is related, this fact about lectures that I was talking about is relevant because it's important to understand that lectures generally, even if you understand everything in a lecture, they usually only give you a very superficial understanding of what's going on. And you have to delve deeper by doing the homework and by asking for clarification, reading the book, and that sort of thing. And this is important because a lot of the advice I see when it comes to, okay, I'm taking calculus, how do I do well? I want to make sure I do well, and what tips do you have? And a lot of the advice I see is watch these videos. Like watch Khan Academy or whatever YouTuber, watch these videos. And I don't think that's very good advice. That's not the advice I would give. And let me tell you why I don't think that's very good advice. The reason I don't think that's very good advice is because, generally speaking, these videos only provide a very basic understanding of what's going on. Not an in-depth understanding, and they won't provide an in-depth understanding because to get the in-depth understanding, you would have to do things like the homework and ask questions and just spend more time thinking about what's going on. And usually in videos, most people watching videos are not thinking a lot about what's going on. You have to actually really try to understand what's going on and do examples and get stuck and ask for clarification and do those sorts of things to build up your knowledge. And those are things that you wouldn't be doing just by watching a video. So I think videos are okay for getting an introduction. Like if you miss class, okay, then watching a video could be okay. But as I was saying about the lecture, it's really the beginning, not the beginning, middle, and end. It's just like an overview. So one analogy, which is sort of stretching, it's a bit of an exaggeration, but I think there's a lot of truth to it. Like let's say that you want to do a new workout. So you're looking for a new workout and you find this playlist of workout videos and you watch the playlist. So you watch these videos where someone teaches you how to do the workout, how to do the weights or whatever, I don't know. And you watch the videos because people said they're good, and 2 weeks later, you're asking yourself, well, how come I'm not any stronger, right? How come I haven't seen any results? I mean, you could say, well, I spent all this time watching all these videos, how come I'm not getting any stronger or seeing the results that I want? Well, we know the reason. The reason is because there's a difference between watching the workout video and actually doing the workout, right? So, in the same way, there definitely are students who will spend an enormous amount of their day watching math videos, right? These are educational videos, they're math videos, right, on YouTube or wherever, and they'll still fail the test. Or they'll spend lots of time reviewing their notes and they'll still fail the test. And the reason is because they didn't actually do whatever the analog of not doing the workout is in math. Like they didn't actually spend the time thinking about the material carefully and understanding how it works and asking questions and asking for clarification and practicing and making sure that they really, really get it thoroughly. And it comes out, like you can see it in how they respond to the test questions. So that's how I feel about these videos. It's fine as an introduction, but you shouldn't say, okay, I'm gonna watch these videos and then I'll learn linear algebra, or calculus, or differential equations, or whatever math it is, statistics, whatever. In the same way as you wouldn't watch a bunch of workout videos and say, well, now I did the workout, right? Nobody thinks that after watching a workout video that you somehow did the workout. And it's the same with math. Okay. So when you're trying to learn this stuff, ask yourself questions. You think like active learning, not passive learning. Because if you're passively trying to learn this stuff, you're not going to learn a whole lot. So active means, I don't mean physically active, I mean mentally active. So you're asking yourself questions, you're thinking about what you're learning, you're not trying to do this in a rush. You're really asking yourself, okay, how does it work? Why is it working? Why do I do this step and not that step? What happens if I do this step? Would this be an alternate way of doing it? Or usually in a math problem, there's multiple different ways of doing it. How else could you do the problem? Or what happens if you change the number from 5 to 6? Would I be able to do the same steps, or would it be different? Or, okay, I'm learning this concept. How does this concept relate to a different concept? I'm learning implicit differentiation. How is that related to the chain rule, or the product rule, or whatever it is? Or I'm learning about integrals, like substitution, and substitution is related to the chain rule. How is it related to the chain rule? Right? Or just why am I doing this step? Why am I doing this process? Instead of just, okay, I have to do this step when I have this problem. Or this is how I do this problem, this is how I do that problem. So that kind of level of understanding, where you understand why, not just that you're doing these things, but why you're doing them, is really important. Because if you just memorize 1,000 different things, I already know what's going to happen. You're going to fail the class. You're probably not going to do very well. You're going to be asked one thing, and then you'll end up doing something else, which is for a different thing. And if you don't understand what's going on, you're not even going to know why what you did doesn't work, right? So instead of learning, think about a network of facts. You're trying to learn. It's one of the things that's nice about calculus, is that you're not learning a bunch of isolated facts like this. Do you see these dots I'm drawing? Oh wow, what happened? How come there's no dot? Oh, did I? There should be more dots, but let me try. There you go. There we go. Right. This isn't what you're trying to know. These 10 dots that I'm drawing. Because usually, so these dots represent facts. And if you try to memorize all 100 or 1,000 of these dots, you're going to have a lot of trouble. The point is that this dot is related to that dot, and that dot's 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 related to that dot. And you're trying to understand a network of facts. Okay? The derivative is related to the integral, the limit is related to the derivative. You're not just memorizing a bunch of random things. And the more you understand why, okay, how come you have to take the first derivative and set it equal to 0, or why do you make the number line like this when you're trying to see if the function is a max or min, or whatever it is, an inflection point. If you understand why it works, you're going to have a better memory of of that it works, of what to do. Because if you try to do something that doesn't work, you're going to know, because you understand how it works, that it's not going to work. Like, of course you wouldn't do this step because it doesn't make any sense. Right? That's something you can only do when you actually understand what's going on. So one thing that students do that I think is not, that I sort of understand why they do it, but it's not effective in the long run, is they try to rush through everything. They say, well, you know, I have to do all these other things, and I have to work, and I have a job, and I have other classes to do, and to take care of. I have other things I need to do, so I'm just going to rush through the materials as soon as I can, and just try to pass the class while doing the bare minimum. Or they'll say, okay, what grade do I need to pass this class? I'm going to aim for that percentage. So if I need a 60%, I'm going to aim for 60% and not aim any higher. And that sometimes backfires. So they might aim for a 60% and then they get a 50% and then they fail the class and then they have to retake it. Or they don't spend time trying to understand what's going on because they're just trying to rush through everything, and then as a result, they bomb the test. Right? They bomb the test as a result of the way they're going about the class. It's not that they can't do it, it's the way they're going about the class that is leading to them not getting the results they want. So make sure that if you're going to take calculus, make sure that you allot plenty of time for calculus. Don't rush through it. Take your time and try to understand it thoroughly instead of at a superficial level. Okay, so that's number 4, right? Actively learning, not passive. Okay, and related to that is go to office hours. So what are office hours? So the professor should have a certain amount of time allotted during the week to take questions that you have. That's what office hours are. And I would recommend that you go to office hours regularly. So regularly, not just regularly means not once a quarter or once a semester. I mean, once a week or once every 2 weeks. That's how I would recommend that you go, how often I would recommend that you go. So come up with some questions and go up to them and ask them those questions and see what they say. And sometimes instructors are much better at one-on-one than in a large group. So they might, in any lecture, if you go to a lecture with 150 students and you try to, no matter what you say, if you're explaining something for like 50 minutes to a group of 150 students, students are going to be confused. There are going to be some students who are going to be lost. It's pretty much impossible to talk about anything for an hour in a group of 150 students and have them not be confused or lost for the entire hour. That's just not something that is likely to happen. So no matter what the professor says, students are probably going to be confused about something. So that's just natural. There's nothing wrong with that. That's just the way it is. So you're a beginner, you're taking calculus, you are not an expert in calculus. That's why you're taking calculus. So some students are hesitant to go to office hours because they're afraid of asking for help because they don't want to look stupid. Now, I understand not wanting to look stupid. Okay, but why am I saying this? Because I want you to go to office hours even if you might look stupid. Because you are a beginner, your professor doesn't expect you to be an expert. That's why you're taking the class. You are going to have questions. And what questions are you going to have? You are going to have questions about the most basic things. Like, how do you go from this step to that step? Right? That's a very typical question that students have. Well, how do you go from here to here? or why did you do from here to here, or the book says that blah, 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 how come that's true, right? Those are perfectly good questions. You don't have to have mind-blowing, amazing questions. Just any questions that beginners are going to have, you will probably have. So the questions about the most basic things, that's fine. Now, some professors are reluctant to answer questions that are about algebra or pre-calculus because you're taking calculus. And they don't want to go over the quadratic formula or factoring or things like that. So if you find out that your question is really because you don't know how to factor or something like that, or it's really not a calculus question, it's more of an algebra question or pre-calculus question, the professor might be reluctant to answer. Well, okay, if that doesn't work, try asking your TA, or ask your, go to the Math Study Center and see if there's someone who can help you. There are usually lots of resources, and you might have to be a bit persistent in using these resources. So let's say that you are going to a TA and you ask the TA a question and the TA answers the question, but you don't understand. Okay? If that happens, I would encourage you to say, okay, I don't understand that. Like, I understand that you're answering the question, but I don't understand what you meant by this. And then ask for clarification. So it's important to be a bit persistent, not annoying, but persistent. Just if someone explains something and you don't understand, then say that you don't understand and see if you can get a different explanation. So you don't have to say, okay, I didn't understand that, I'm never gonna ask you any more questions. It's natural, it's just a part of communication that people might say things that you don't understand. Okay, that's totally normal. So just ask for clarification. Tell them, okay, I understood this part, but I'm still confused about what you meant by this. Or you could ask the person that you're asking, could you write it down? So, and maybe because it's complicated material, the explanation is okay, but it just takes time for you to understand what's going on because there's a lot to think about. So if that happens, and that's very common, that happens to me all the time, you could say something like, okay, let me think about it a bit more. I just need time to think about it. That's a really good way of saying that you don't really understand what they're saying, but it's not them. It's not that their explanation was bad. It's just that you need time to think about it. And usually if you say that, people will say, oh, okay, and then that's it. And then if you think about it some more, and then if you have questions, then you can ask for clarification. Sometimes there are things that just don't make sense, but then you go to bed and then you wake up the next day and it makes perfect sense. That happens a lot. That actually, there's science behind that. When you sleep, you're not, unconscious, or you're not like dead, and then you just wake up and then you're alive. Your brain is actually at work when you're sleeping. So that's really interesting. So. And that's another reason why it's important to not cram, because you're not taking advantage of those sleep cycles. So try to learn at a gradual pace so that when you're sleeping, you're actually learning while you're sleeping. Okay, and related to that is explore different options. So usually there are lots of different opportunities to ask for help. Like there's office hours, but then the Math Study Center, there might be an intercultural center that has people who can help. And you might gravitate towards one as opposed to the others. But I would encourage you to try all the different opportunities. So some of these resources might not be as effective as others. Okay. How come? Because oftentimes these resources I don't want to say anything specific. But usually the people mean well, but they might be undergraduate students who just happened to do well in the course when they took it. And they were hired to work in a math, study center or something like that. Okay. They might not be able to answer your questions as well as a graduate student if you have that opportunity, or your professor. Because if it's calculus, maybe they haven't taken calculus in a while, or maybe you're asking something that's very specific to a lecture, and that person that you're asking isn't familiar with what that professor was saying in the class, and so they have trouble connecting that to the homework problem. So maybe there's a homework problem that's related to something the professor mentioned in class, but because that student doesn't know what that professor was talking about, they can't make that connection. So there are all sorts of reasons why some resources might not be as effective as others. So I would say that if you can find someone who is familiar with what actually happened in class, so that would be a professor or a TA, talk to them, and they would probably be more effective than another resource, than someone else who may not be as familiar with the class. Okay. And like I said, be persistent. So sometimes students will just go one time and then they'll have a non-optimal experience. Like they'll go to the math center and then go to someone, and then that person's not very helpful. So then they just say, okay, I'm not gonna go to the math center anymore because they're not helpful. That's not a good idea. Okay, first of all, it could be that that person was trying to be helpful, but you didn't say that, you didn't ask for clarification, and because of that, they didn't give you any clarification, and that's it. Like maybe if you had just said that there was something they said that was confusing, then they could clarify that, and then you would have had a better experience. Okay, so going back to being persistent. Another thing is maybe sometimes there are just people who are better at explaining certain concepts than others. They just might have more practice or more experience explaining calculus concepts. So if you go to someone in the Math Study Center and you tried and it just didn't work for you, then try asking someone else, right? There's like lots of different people you can ask. That's totally fine. Just say, okay, I'm gonna ask someone else, and then go to that other person, and you might have to look around until you find someone, but you probably will be able to find someone whose explanations you do understand and that you find helpful. Okay. So going back to being persistent, and just to repeating myself, but just don't just use one resource. Try to use different resources and just be aware of the resources that are available. Okay. So I'm saying that a bunch of times because I had a student once who went to one resource. This was the resource where the people who helped weren't familiar with the lectures and things like that. And they did go to try to get help, but it wasn't very helpful. Or it wasn't as helpful as it could have been because the person that they asked for help wasn't familiar with the lectures or things like that. Or sometimes they just said things that weren't very accurate. So sometimes I would think, well, you should have just seen me, or you should have talked to a TA, or should have talked to a professor. That would have been better. So that's what I mean by take advantage of all the different resources that are available. Okay. But you have to be careful with online videos because sometimes students will look up online videos and they might look up things that are not relevant. So they might look up something that doesn't actually relate to the homework problem they're trying to do, but they don't, because the student doesn't understand, they don't understand that video that they watched is not relevant to the homework that they're trying to do. There are all sorts of reasons why just looking things up online is not optimal. It's usually better to go see someone directly, like a person, right? A person. Go talk to a person one-on-one. That's usually better than looking at videos. And what happens if there's a conflict with office hours? Then in that case, so let's say that your professor has office hours on Monday from 3 to 4, and you can't make it on Monday from 3 to 4 because you have to work, or you have a lab, or you have another class, or whatever. You're playing a sport or something, and that the practice is from 3 to 4, and you can't make it. Well, if that happens, then what you do is you don't say, well, I guess I'm just not going to be able to get help. What you do is you go to your professor, you walk up to them and say, I want to go to your office hours, but there's a conflict with that time because I have to do something else. Is there a different time we can meet? And see what they say. Usually professors are able to answer questions outside of office hours. Here's how I think about office hours. Now, not everyone will agree with me. It's just my perspective. Have you ever filled out a form where you kind of just have to list something? So you have a form where they just ask you what you do, and you just put down something because you know it doesn't matter. You just write down something. That's what office hours are like. So at the beginning of the term, the professor's writing the syllabus, and then there's a line for office hours, and then they have to think, okay, what are my office hours going to be? And they come up with a time that's convenient for them. They put it down and they say, okay, that's my office hours. That doesn't mean that that's the only time you're allowed to ask questions to the professor. You probably are allowed to ask your professor for questions outside those hours. Right? The hours are just something that they put down. It's something that they just need to schedule time doing. It's not, okay, if you don't ask me from this time to that time, you're not allowed to ask for help. That's not what it means, okay, when it comes to office hours. So just be aware of the different opportunities there are, and be open-minded, and don't say, well, I can't do this, I can't do that, I can't do that. You probably can. Okay. And I'm saying this because I just see this a lot of time in students. They just say, well, I can't ask you for help, I can't do this, I can't do that, I have to figure out all on my own. No, you don't. There are resources out there, but you just limit yourself because you tell yourself certain messages that are limited. So don't be that student who just says, I can't do this, I can't do that. Because if you tell yourself that, you probably can't do that or that. Right? Okay. And another tip, so number 6 is, well, this is a long video. As you do the homework, this is the last tip. As you do the homework, ask yourself if you can do it on your own. Okay. This is important. And I made a video a while ago about exams and how a lot of the time professors just look at homework problems and just copy homework problems and put that on the exam. Not all the time, but a lot of the time. And so when you're doing the homework, ask yourself if you can do it on your own. It's like, to go back to that analogy with the exercise, it's like, let's say that one of the things that you would want to do is a pull-up. Like you have to do a certain number of pull-ups or something. And during the homework, you're asked to do a pull-up. And you can do the pull-up if you have someone helping you. This is just a made-up thing. That doesn't mean that you can do the pull-up yourself. You can do the pull-up if someone was helping you. And it's the same with the math homework. So you have this problem with the, finding finding the inflection points or classifying the local maxima or minima or seeing like what value will optimize something like that. And you can suppose that you needed to take like 4 attempts to do the problem. So I'm saying this because a lot of the time, if there's online homework, you might get multiple attempts. So let's say that it takes you 4 attempts to do that problem. So after the 4th try, you finally got it right. Well, on an exam, you're not going to have 4 tries. You're not going to have something saying, well, this was wrong, try again, this is wrong, try again, this is wrong, try again. Hey, you got it on the 4th attempt. No, you're not going to have that. You're just going to be given the problem, and you have to just do your best to answer the problem, and then move on to the next question. Well, if you got it on the 4th attempt, then okay, you got it on the 4th attempt. Try doing it again. Try to get it right on the 1st attempt next time. Right? So usually there are, for that sort of online thing, you could try to ask for a new randomization. So it's like a similar problem, but with numbers different, and try it again. Try to do it right on the first time, and keep trying it until you can successfully, consecutively do it right, and to the point where there's just no way you're going to mess this up if you're asked that question on the test. That's the level that you should be trying to get at. Right? So if it's like, okay, you finally got it right on the first try, that you shouldn't think, well, on the test, I'll definitely get it right on the first try, right? You should keep trying this until you say to yourself, okay, if I'm asked this question on the test, I'll definitely get it right. I'm very likely to get it right. That's the level of fluency that you would want to make sure that you have before you take the test. Okay, so those are my tips for learning calculus. Again, the first one is the most important, the algebra and pre-calculus. And I explained that you can look at an algebra book or the first chapter of a calculus book to do some review or some old exams. Review your notes after class. After class, don't just put your notes away, and be aware that lectures are really just the beginning. So don't just go to a bunch of lectures and watch a bunch of videos and think that, okay, now you know calculus. You probably don't. If you ask your professor, how did you learn calculus? They're probably not going to say, if you ask your professor, hey, how did you learn calculus? Did you just watch a bunch of Khan Academy? They'll probably laugh at you. They'll probably be like, no, they actually did the work. They didn't. Watching Khan Academy or watching YouTube videos, to me, is not doing the work. That's not working hard. That's hardly working. When you're watching YouTube videos, you are hardly working. Working hard means that you're thinking hard. You're thinking about what you're learning. You're asking yourself questions. You're coming up with examples. You're asking yourself, okay, how does this concept relate to a different concept? You're practicing. You're doing challenging problems, problems that are going to push you to understand the material to a deeper level. And things like that. You're really asking yourself, how does it work? Why does it work? You're trying to get a very good understanding of what's going on. And if you think about calculus that way and not just something that you have to rush through, you really take your time and spend time trying to understand what's going on, you're going to be much more likely to actually learn calculus. And related to that is, think active learning, not passive, because if you're trying to absorb this stuff passively means you just kind of sit there. Yeah, and going back to that, I mean, I think a lot of students, a lot of people, maybe a lot of people in the general public, think that your brain is just this bucket. They have this model where, okay, my brain is this bucket, and all I have to do is just go to the class, and when I go to the class or watch the video, the professor or the person making the video is just going to pour knowledge into my brain, and then I'll have knowledge. Right? Well, that is not a realistic picture of how learning works. The fact is that the lectures and the book is like the raw material, but you have to build up your own understanding of what's going on. Like you have to, it's like making a house, and the lecture is like the wood and the bricks and the raw material, but you have to build, you have to use those materials and resources and build up your own understanding of what's going on. It's like making a house out of the material. That's the kind of silly analogy. It's not just given to you. So this stuff, like calculus or whatever math you're learning, the understanding isn't something that someone can give you. You have to generate your own understanding of what's going on. And that's an active process, it's something that you do, it's not something that happens to you. It's not something that someone does for you. It's something that you generate yourself. So if I had to give one piece of advice, it would probably be that. And acquire a network of facts, not isolated facts, not just memorizing a bunch of random things. You're thinking to yourself, how do these concepts relate? How does this fact I learned relate to another fact? And you realize that you're a beginner, you're learning this stuff for the first time, and because you're a beginner, you're going to have questions, and you're going to have questions that beginners in any subject are going to have. And it's important for you to have that opportunity to ask those questions so that you get those answers. So office hours isn't for students who are failing. It's not, okay, if I'm borderline failing the class, then I'll go to office hours. No, you go to office hours even if you're doing okay in the class, because you probably will have questions, and that's an opportunity to ask those questions. And take advantage of the other opportunities of, again, if those office hours don't work, then try to schedule an appointment. Right? So a lot of professors are available on Zoom. So can you meet at a different time? That sort of thing. I'm taking initiative, being persistent, that's really important. And the last step is also, as you do the homework, ask yourself if you can do it on your own, so that when it comes to a test, you will be able to do it on your own. And I have a video on tips for test taking in math classes. And if you haven't watched that, I would encourage you to do so. And that's it. And good luck with your calculus class.